Hello, this is Saswat Parasar Behra, and this presentation covers the literature review for our project titled Time Series Transformers for Stock Market Prediction. The objective of this review is to analyze existing forecasting approaches, understand how transformer based models are being applied to financial time series data, and identify the gaps that motivate our research. I will begin with the traditional forecasting approaches and move through deep learning and transformer architectures, and then discuss specialized models such as time to wake and stock former. And I will conclude by summarizing the gaps in the existing literature and explaining how our work aims to address them. Um, we first studied classical statistical models such as ARIMA and SARIMA. While these models are mathematically elegant, they assume linearity and stationarity. Uh, in practice, financial markets exhibit nonlinear behavior, and these models are not a good fit and they do not capture the patterns effectively. Uh, so subsequently we moved to RNNs, LSTMs and GRUs. They improve the performance by learning non-linear sequential patterns, but they process data sequentially, which makes training slow and limits their ability to model long range dependencies. This becomes a major bottleneck for large volumes of time series data. The transformer architecture introduced in the classical attention is all you need paper removed the problem of recurrence and allowed models to be trained parallelly. This parallel processing and the significantly improved modeling of long range dependencies makes transformer a more promising candidate for financial time series forecasting. But vanilla transformers cannot be directly used to model financial data. They were designed originally for discrete tokens and use fixed positional encodings and are highly sensitive to volatility and noise. So this often leads to overfitting on limited financial data sets, and capturing financial data is usually very expensive and acquiring data is expensive. So our initial training requires to be suitable for limited volumes of data sets. Several transformer variants have been proposed for time series forecasting, including informer, autoformer, and fedformer. While these models improve efficiency and long horizon forecasting, they struggle with event driven market movements and decomposition based assumptions, which often fail when the financial environments are chaotic. Time to wake was proposed to learn both periodic and non periodic temporal patterns. This is particularly relevant for financial markets which operate across multiple cycles, where we want to derive patterns which are intraday, weekly, and quarterly, or which have some significance related to holidays or other events. However, most evaluations focus on error metrics like RMSE rather than financial performance. Moving to stock former, which introduced multi-feature inputs such as open, high, low, close, volume data, and technical indicators, along with customized attention mechanisms. It improves prediction accuracy, but it still lacks learnable temporal encodings like time to wake, and does not evaluate the robustness across different market regimes. The research gaps that we identified while going across the following literature were that they have weak forms of temporal representations, they lack risk awareness, and they are unable to evaluate the risks, they have minimum regime analysis and limited uh, backtesting that is actually practical. Our project aims to integrate time to work with a multi-feature transformer architecture. We focus on a financially meaningful evaluation metric, not just a single metric but on multiple metrics such as the Sharpe ratio, drawdown, Bollinger Bands, cumulative returns, and other such relevant indicators, along with regime based performance analysis. The goal is to develop a model that is not only accurate but also practical and interpretable for real world trading. Uh, in conclusion, transformers offer strong potential for financial forecasting, but they require domain specific adaptations. Our literature review establishes the foundation for extending the work that has been done towards a more robust and financially meaningful model. Thank you.